Good morning, students. Today's session we are going to discuss about schedules in the DBMS. The last two class we are discussing about transactions and the asset properties. Now we are going to discuss about schedules. A schedule is a chronological order of transactions operations. It means that we have to follow some sequential flow of activities for scheduling the concept in the DBMS. What is the thing when we follow that schedule means that schedules help to analyze individual transactions, then interleaving of transactions in what time that interleaving was taken place, that also it is possible to consider here. Then what is the conflicts between operations when we are doing the transactions, that is also possible to understand in the schedules. Then if we face any difficulties or some errors if we are facing means from that error how it is possible to correct and how it is possible to successfully complete the executions, that is also possible when we are using the schedules. Schedules are classified as serial and non-serial schedules. Here serial schedules, again it serial schedules, it is the sequential flow of activities, so it's not having much importance, but we have to follow some chronological order. But when we talk about the non-serial schedules, it's again divided into serializable and non-serializable. That serializable again it's split into two: conflict serializable and view serializable. Then non-serializable, it is recoverable serializable and non-recoverable serializable conditions. Then recoverable it is again split into cascading schedule, cascadeless schedule and strict schedules. What is the thing we are going to do here? We will see one by one. Normally, serial with non-serial schedules. Serial schedules, one transaction execute fully before another. So we have to follow the sequential flow of activities. One transaction, it will be successfully completed, then only it is possible to uh, uh, consider for another transactions. Like in operating systems, how the resource will be going to utilize by the different type of process like P1, P2, P3, they are accessing the same resource means first come first serve basis, the P1 process, what is the request he was taken given to the server, that the thing will be completed. After that only the P2 process will be considered. That if we the same thing here we are following in the DBMS also. So what is the major advantage? It is very safe because one transactions only we are going to follow, but it is very slow. It is the major disadvantage. When we talk about non-serial schedules, it is operations interleave. Suppose we are facing some difficulties like power cut or system failure or some network failure, uh, our transactions will be stopped in between the flow of activities. So at the time, how our DBMS will be handle that situation at the that is called as a non-serial schedule. Then it gives the improves performance because we are giving solution for that type of scheduling process. Suppose power failure or a system crash or network failure will taken place in our transaction means what is the solution for that one, then how we will recover, like that we are giving the solutions in the DBMS itself. So it improves the performance of the DBMS. It requires concurrency control. Yes, definitely the non-serial schedule it will maintain the concurrency control because entire flow of activities it will maintain the concurrency. Most of the real world database nowadays they are using the non-serial schedules because almost all of the websites in cloud platforms now we are started using. So that real world database, it is non-serial schedules, because we may depend on different vendor, or we may depend on different network segments, or servers, or online platforms. So anything will happen at any time. So non-serial schedules only we are handling in many of the companies. So that's called as a DBMS. Nowadays we are maintaining the non-serial schedules. Then problems in concurrent executions. Concurrency may cause last update overwritten. Yes, when the transaction failed, what will happen? It is interrupted, and the system will stop that in the current situations. Then again, if that system was corrected, means from where that customer was leave, from there itself we have to start. So it's called as a last update. What is the thing? What is the thing we are saving? It will be updated. For suppose, let us take an example. If you are filling some applications form in the online itself, at that time system failure or a network failure was happen, means 2 3 pages you already filled. After resuming our network or power, uh, we no need to uh, enter all the information from the beginning itself, from the beginning to end, where we are stopped or where we are facing that problem. From that place itself, that application form again we have to go and fill. That's called as a last update conditions. So we have to maintain the concurrency in the DBMS. Dirty read, reading uncommitted data. Suppose sometimes what will happen, that conditions was not completed full flow, but people will started reading that data, means it is called as a dirty read. If it happen, means what will happen, that data result may be false informations or faulty informations. So we have to avoid that also. Unrepeatable read, same read gives a different result. For example, in student attendance, first click, if they are it shows 1% of attendance percentage, and the next click it shows the different percentage, and third click it shows the different percentage, means the people don't believe that one, when they believe the system. So it is unrepeatable read. Each time it will shows the same information, means people will feel that it is right data. These problems leads to data inconsistency. If we not for fix these issues, means what will happen, customer or user may feel like that here the data was inconsistency, so it is not accurate data, it having some issues. So don't consider, you go for manual process of activities. So a very important thing here is, when we design a database, at that time we have to give importance for schedules. From that schedules we have to give importance for different type of scheduling process of activities. Then we have to give more importance for concurrencies, like last update, dirty read, and unrepeatable read. We have to avoid it, and we have to maintain the consistent database for user. So this is the important thing when we discuss about the RDBMS. Thank you students for listening this video. It may be useful to your database design, I think so. Thank you very much.